All right, now for our third and of the four conics that we'll be covering here in this unit. We talked about circles, so that's where your sheet goes right through the paper, parallel to the bottom of the cone. So there's your circle right there. We just got done talking about ellipse in the last video, and that's where you take that sheet of paper and you come in at a diagonal, so you get this oval-looking thing. We're going to take the sheet of paper and we're going to get what looks like two parabola-looking things. Now, the equation for an ellipse isn't a whole lot different from the equation of a hyperbola. Ellipse had the plus. The hyperbola is not going to. There's still going to be an a squared and a b squared. There's still going to be vertices, but no covertices. And there's also foci. The only thing that's going to get added here are going to be some asymptotes. But anyways, here we go. With hyperbola, again, there's going to be a minus in between the two x squared and the y squared. Now, you tell the major axis and the minor axis based on which one's positive. So right here, I see x is positive, so the x-axis is going to be my major axis, so it's going to open up on that x-axis to the left and to the right. And it's going to look like two parabolas, kind of mirror imaging of each other. The center for now is always going to be 0, 0. We'll move those a little bit later. Okay. Now when y is positive, the y-axis is going to be your major axis. So now it's up and down like that. Okay, and again, your center is going to be 0, 0. So it's very similar to the ellipse where it's got to be equal to 1. There's an a value and a b value. But what's different about it now is that there's this minus. And if you notice that the foci formula here, I guess I didn't have that labeled, it's a plus in between the a squared and the b squared. I kind of remember it like it's Pythagorean theorem, but it's opposite of the equation I'm given. For instance, hyperbola has a minus in between the x squared and the y squared. So in between a squared and b squared, it's the opposite of that, so plus. It's kind of the same thing on the ellipse formula too, if you go back and look at that. So here's what we're going to do. We are going to graph the center. We are going to move how many units to the left or to the right on the x-axis, move how many up and down on the y and the x. And by the way, that's all based on your a and b. We're going to draw this box. It's going to help us draw these dashed lines called the diagonals or the equations of the asymptotes. Okay, now if you remember from the rational equations, asymptotes are lines that the graph will get really close to but never quite touch. And then we'll get a rough sketch of that hyperbola. We're not going to make a table. We're going to kind of use the asymptotes as our tool to decide how open or wide those parabolas should be. And then finally, we're going to find the foci and then we're going to graph. So here we go. A little bit different. Whichever one is the positive value determines the major. So here, a squared goes below 9. So that means my vertices are going to be counted off by a unit of 3 because it's square root of 9. Like I said, the center is going to be 0, 0 for a while now. And since x is positive, I'm going to go over 1, 2, 3 to the right, 1, 2, 3 to the left, and there's my vertices. So at negative 3, 0, and 3, 0. There's my b squared, so b is going to be 4. And I'll start off with dots, but I'm really not going to use those dots. The only reason I'm going to put those dots down is I'm going to use my 3 to go up and down and make a box here. And that's going to help me draw my asymptote. So if I go from one corner to the other corner and go through that center, there's one asymptote. Okay, do the same thing over here. There's a second asymptote. Now, how that's going to help me is my parabola is going to start at the vertex and it's going to go through that, and it's going to go really close to that asymptote but not touch. And that's as much of the accuracy of the graph that I'm really looking for. Do the same thing over here. And there you go. So the equation of my asymptotes, we can do point slope form, which is that right there, where I can grab a point and I'll use 0, 0 for now. And the slope, which is basically just me going from one diagonal to the other, going up 1, 2, 3, 4, and over 6. So 4 over 6. It's going to be y is equal to 2/3 x. Well, that's the positive sloped line. It's also going to be y is equal to negative 2/3 x because of the negative slope line. Okay, your foci, remember, it was c squared is equal to a squared minus b squared for ellipse, but since it's a hyperbola, we'll put a plus. So now it's 9 plus 4, 13, or the square root of 13, which is roughly, and again, I'm just estimating off the top of my head, maybe like 3.8-ish. But anyways, it's going to be somewhere in here. Now, on the negative square root of 13 comma 0 and positive square root of 13 comma 0. So you're going to kind of curve around those foci. Okay? Kind of like the foci were on the inside of the ellipse and they curved around that. Circles don't have an ellipse. It's called just the center. Or I should say, circles don't have foci. It's just the center. Okay, so now y is positive, so there's my major axis. Okay, so that's going to become 4 that I'm going to use. So I'm going to go from here, center again, 0, 0. Go up 1, 2, 3, 4. I'm going to go down 4. Okay, I'll use that 3 to form the box along with my, so that's why there's no co-vertices. It's only going to touch the vertices. And then those diagonals are my asymptotes. And there's my one part of my hyperbola going up. And there's the second. So the asymptotes kind of decide how wide or narrow it is. Okay, again, I'll use 0, 0 for x1 and y1. That's a point that's on my graph. And I'll go up, let's see, I guess it's going to be 8 and over 6. But it's basically going to turn into, from the center to this corner, so up 4 over 3. There's the positive sloped one. There's the negative sloped one. Okay, and then the foci. C squared is going to be a squared plus b squared. So 16 plus 9, 25. Square root of that. So 5. So on the y-axis, 0, 5, and 0, negative 5. Okay, again, these have to be equal to 1, so I'm going to divide by 100. Reduce these down. I get a 4 and a 25. Now, careful. X squared is the positive one, so x is still my major axis. Okay, so I'll take the square root of 4 and I'll get 2. Again, center is going to be 0, 0. So from my center, we'll go over 2, over 2. So my vertices, negative 2, 0, positive 2, 0. And I'm going to take the square root of 25, which is 5. So I'm going to go up 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. It's going to help me get that box. And my diagonals. So I'm going to go up 1, 2, 3, 4, 5, and over 2. So I could just basically go plus or minus 5 over 2x. And here is where it's going to open. Oh, sorry. I take that back. My x-axis is my major axis. So a really couple of big, wide guys. So as far as foci, 25, which is 5 squared, plus 4, 29. Take the square root of that. So I got minus the square root of 29, comma 0, and the square root of 29, comma 0. Those are my two foci. Okay, so to write the equation of my hyperbola, here's what I'm doing is I've got this graph paper there just kind of as a help because maybe I don't visualize it as well without seeing that the vertices are on the x and y axis. So now I know the y axis is my major axis. I know it's going to be y squared over 25. And I got that 25 because that's 5 squared. I'm given the foci, so I'm going to have to use that to go c squared is equal to a squared plus b squared. So 13 squared is equal to 25 plus b squared. 169 minus 25 is 144. So the square root of that is 12. Or I'm just going to go and square that again. X squared over 144 equals 1. And it's a hyperbola, not a ellipse, so that's got to be a minus. Okay, 0, 0. Again, I'm going to put my vertices on here just to help me visualize it. All right, so this is my major axis. So that means x squared is positive and y squared is going to be the one that's negative. Over 16 because of 4 squared. Last time I've given my asymptotes, so it goes up 1, 2, 3 over 4. And where that helps me out is that b value right there is 4. So I could go, I'm sorry, not 4, 3. I counted wrong too. On my graph should be right there. Up 3 and over 4, so that dot should be right there, and my line should be a little bit farther slope. But there's my 3, so that's going to tell me that b is 3, so 3 squared is 9 equals 1. And there is the equation of that hyperbola.